Okay, so in the last section, we were looking at three trig functions, which are sine, cosine, and tangent. Remember, sine is the ratio of opposite over hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. Tangent is the ratio of opposite over adjacent. Well, today we're going to be looking at something that's called the law of sines, and we use this when we have any triangle. It does not have to be a right triangle. So sine, cosine, and tangent are normally thought of as working with right triangles, but here we're going to work with any triangle. So here's what the law of sine says. It says if I have angles A, B, and C, and notice how they're all capital, and then across from angle A, we have side length A, and that's a little a. Across from angle B, we have side length B, which again is a lowercase b. And across from angle C, we have lowercase side c. Then we can use this here, law of sines, where if I take sine of the angle at A and divide that by the side opposite, that must be equal to sine at the angle B over the side opposite, which is also equal to sine of the angle C over the side opposite. So you need to write down this law of sines here as your big note for this section. Okay, so here we're going to be using our law of sines in an actual problem. So I'm looking at triangle XYZ. It wants me to find the length of YZ to the nearest tenth. So I'm looking for the distance here from Y to Z. Okay, I don't know that distance. I'm going to call that missing distance X. So now what the law of sines tells me is if I have an angle, like say here, look how I have angle Z, and I know the side opposite that angle Z. So I have 77, and I know the side opposite 77. It has a value of 7. So the law of sines says if I take sine of angle Z and divide it by the opposite side, little z, that must be equal to sine of the big angle X all over little x, right? That's the unknown, what I am looking for. So now if I plug in these values, what is angle Z? It is 77 divided by my side length Z is 7. That must equal sine of angle X, which I know is 51 over the opposite side, which is X. When you set up these law of sine problems, you can only have one unknown. Like here is my one unknown. If I have more than one unknown, then I can't solve this law of sines problem. So here's how we solve this. This is a proportion, a fraction equal to a fraction. When I have a fraction equal to a fraction, I'm going to cross multiply and set those two values equal. So x times sine 77 is going to give me x sine 77. And then 7 times sine 51, let's just leave that as 7 sine 51. Just like this. Now I'm trying to solve for x. X is being multiplied by sine of 77. So I'm going to divide by sine of 77 on both sides. So now these cancel. That leaves me x equals. And now my calculator, I'm going to type all that in at one time. So I'm going to type in 7 times sine of 51 degrees divided by sine of 77 degrees. And again, make sure that your calculator is in degrees mode because we are working with degrees right now. Okay, I've just double checked mine. And I get x is equal to 5.58, which if I'm rounding to the nearest tenth, that's going to round up to be 5.6. So my missing side here would be 5.6. Now, a way that we can check, does this kind of make sense? Well, this is the side that's opposite the 51 degrees. So this side here, x, would be 5.6. Well, that's smaller than side 7. And notice how 7 has a bigger angle across from it. So the bigger angle has a bigger side opposite it, and the smaller angle has a smaller side opposite it. So it at least makes reasonable sense that this could be the answer. It turns out that that is the correct answer. Okay, I'm going to give you a minute to think about this one. and see if you can solve it. Notice here that I'm looking for segment XZ, which is here in yellow. So in order to find this side, I'm going to call it little y, right, that I'm looking for. And so I need to have the angle opposite it, which is big Y. So think for a minute, how could I find that missing big angle Y? Hopefully you figured it out. You've got a triangle that you know is 180 degrees. And you know two of the angles in that triangle are 51 and 77. So I can subtract those from 180. And I found that the missing angle must be 52 degrees. So now when I set up my law of sines, again, I have to have one matching pair that I already know. So I know opposite 77 is side 7, so we're going to use that again. Sine of 77 degrees divided by 7 must equal. Now if I'm looking for y, I'm going to use sine of 52 degrees divided by my unknown y. Fraction equals a fraction, cross multiply. Y times sine of 77 equals 7 times sine of 52. Y is being multiplied by sine of 77. So I'm going to divide by sine of 77. Again, this is going to cancel and leave me with y equals. And then type all of that into your calculator at once. 7 times sine of 52 degrees. And this has to be divided by sine of 77 degrees. And when I did that, I found y must be equal to 5.66, which I can round up to 5.7. Okay, here, it's asking me to find the measure of angle R and the measure of angle S. So this time my unknowns are the angles, where the last time my unknowns were side lengths. Okay, very interesting. So the first thing I have to do the law of sines is I must have a pair that is already complete. So when I'm looking for angle R, do I know the side opposite angle R? I don't. So that's a bad place to start because it doesn't have a complete, it doesn't have either one. It doesn't have an angle or the side opposite. If I'm looking for angle S, do I know it? I do not, but I do know the side opposite it. It is 12.7. And then lastly, I know angle T is 74. And I know the side opposite it is 12.3. So that's the pair I'm going to start with my law of sines. So I'm going to have sine of the angle, which is 74 degrees, divided by the side opposite, which is 12.3. Now we talked about this. I can only have one unknown. So if I try to find angle R first, I don't know angle R, and I don't know the side opposite R. So that's a bad place to start. So instead, the better place to start is to find angle S, because I do have a known of the side length opposite S, and it's 12.7. So as I plug in here, I'm going to be looking for sine of the angle S, I don't know what that is, over the side opposite is 12.7. So hopefully that setup makes sense to you. Now, just like we did before, we're going to be looking to find S. Again, the difference is S is an angle this time. It's not a side length. But when I have a fraction equal to a fraction, I'm going to cross multiply and set those equal. So I have 12.3 times sine of S must equal 12.7 times sine of 74. I try to get S by itself. The first thing, S is being multiplied by 12.3. So I'm going to divide both sides by 12.3. That's going to tell me that sine of S equals, and then I have that very long math statement there, 12.7 times sine of 74, all divided by 12.3. Now, if you'll remember back to last lesson, if I'm trying to get S by itself, but I can't because I'm taking sine of S, then I have to undo that sign. And the way we undo sine is to use what's called an inverse sine. Again, on your calculators, you're probably going to have to hit shift sign or second sign to find the inverse sign. So the inverse sine of sine, those cancel and leaves me with S. And I'm going to put all of this in my calculator at once. So what I'm going to enter is, I'm going to click second sine. That means I have the inverse sine of, then if you have a Casio, hit your fraction button. Go ahead and put 12.7 times sine of 74. And then this is divided by 12.3. Again, make sure your calculator is in degrees. When I do this, I find that the S value must be 82.98, which we can round that up to 83 degrees. So my missing angle S here is 83. So now if I know angle S, let me write it here, angle S is 83 degrees. Can I find angle R now? I can, because I know two angles out of three in a triangle. So there are 180 total. I subtract 74. I subtract 83. And I find that the missing angle R must be only 23 degrees. So it is by far the smallest angle, which means the side across from it is the smallest side. Okay, so here's this one. I want you guys to try it out on your own. So go ahead and pause the video. See if you can figure out these problems. Okay, so again, this one's asking me for two angles. It's asking me for angle N, which is here, and it's asking me for angle O, which is here. Now, the one pair that I already know, I know angle M is 70, and on the side opposite it is 4. So I know I've got to use that ratio. Sine of 70 degrees over 4 is my first ratio. Now, in my second ratio, I need to choose either the blue or the green angle, depending on where do I know any other information. We can see opposite the green angle, I know that that side is 2. So I'm going to use the green and solve for angle N first. So sine of angle N over the opposite side 2 will be how we need to set this up. Fraction equal to a fraction, cross multiply, set them equal. So I've got 4 times sine of N must equal 2 times sine of 70. And now the math follows very similarly to the last set of problems. I need to divide both sides by 4. That tells me sine of N equals 2 sine 70 over 4. And now to get N by itself, I'm going to have to take an inverse sine of both sides. So again, remember, on your calculator, you may have to hit Shift and then the sine button, or second and the sine button. So the inverse sine of sine cancels and leaves me with N. And then in my calculator, if I put in the inverse sine of 2 sine 70 divided by 4, you should get an answer that rounds to be 28 degrees. So now I know two angles. I know M is 70, N is 28. So I can find the third angle, O, by subtracting from 180. 180 minus 28 minus 70 gives me a missing angle a missing angle N of, no, I'm wrong. I don't know what I'm saying. Angle N, let me label it up there. We found angle N was 28 degrees, so let's get that labeled. So now I'm looking for angle O, and I've already did the math. Angle O must be 82 degrees. So the good news is with these problems, they're not really going to trick you any. They all have to set up the exact same way. You have to know one pair of the angle and opposite side. If you don't, you can't use the law of sines. So even, like, here's the tricky ones. They're going to give you a word problem, but look, this is the exact same as what we've been working on so far. Right? Set it up as sine of 113 divided by 471. And that's going to be equal to sine of 22 over our missing side here, Omaha to turning point. All right, we call that X. So you can see they've got that set up here. And then you're just going to solve. So hopefully you kind of understand this lesson. It's a shorter lesson, so I think that's helpful. But you can go ahead and start on your easy bridge for 8.3.